That?
Yes.
Yes.
Okay, very good. So anyway, good evening. I'm in Denver right at the moment, and I also have a station out in the country where it's a little quieter. And I've been talking about receiver performance for a long time at my website, of course, when that started, but even before that. So, but I'm going to include transmitters because really that's an important issue today on performance, both sides of the equation. So I started testing receivers in 1976, and our choices today are just astounding compared to what we had back then. But we've got some new challenges, so let's take a look at them. If you've been to my website, sometimes I'll get a phone call or an email. They say, well, why is it sorted by close-in dynamic range instead of sensitivity? And sensitivity has been around a long time, but you really it's kind of a non-issue for equipment. Look, the R390A, that goes back to 1954, the Drake R4C, the K3S, and they all have the same sensitivity. That's a sideband measurement, 0.2 microvolts. Often today in an urban environment, RFI, local noise, is really the problem. So sensitivity is kind of a non-issue as far as the individual receiver. Can I hear the DX or not? But then we've got a new term, noise floor, and so I'll cover both of these. So what is sensitivity? It's a 10 dB signal plus noise to noise ratio, normally in a sideband bandwidth, and that goes back for a long time, pre the 1975 noise floor and dynamic range definitions for the amateur world. And then when noise floor came around, it was a 3 dB signal plus noise to noise ratio. So how do you measure that? So you feed in a signal from your signal generator, you tune away from the signal, set a noise level on your analog audio meter, and then tune in the test and test signal, and then it needs to go up 10 dB for the sensitivity measurement, or it goes up 3 dB for the noise floor measurement. So that's just how we do it.
Well, he's an expert that's on.
Okay, I'm going to mute everybody. I'm sorry for the interruption here. Rob, you're going to have to unmute folks when.
Well, I'm not sure. Can you do that? I only see a few people. I don't see everybody at this point.
Yeah, I can do it. Yeah, I should
go
be
ahead.
able to.
You should be able to do it. And I don't know what's going ding dong, but.
Yeah, people, please make sure you're muted here. Go ahead, Rob.
Okay. So, as I mentioned, local noise is really an issue. I would say from 1969, when I moved to Denver, to last year, urban noise went up about 3 dB per decade, maybe a little more in some locations, and that's a lot. So we've got noise sources like line noise, of course, but it seems like it's certainly worse than it was 10, 20, 30 years ago. We have all sorts of chargers today for our phones and you name it. Those are now switching power supplies where they didn't used to be. And of course, the computers are switchers. Even household appliances like dishwashers, washing machines, refrigerators have microprocessors in them. And guess what? They make noise. Sometimes LEDs make racket, DSL, VDSL, and things like that. And then in Colorado and other places, we have grow lights to grow pots. So God, they make terrible racket. So the other major thing that I'm going to talk about is dynamic range, and kind of the 100 dB magic radio. We don't need a 100 dB radio, but that's kind of be a nice round number. And of course, years ago, we never had such a thing. So it's not uncommon today if you really want to have a, quote, 100 dB dynamic range radio. So what is this? It measures the ability to work a weak station in the presence of lots of strong QRM. And when the term was defined in 1975, the testing only did at a 20 kilohertz spacing, and that was okay for the most part for radios that designed in the 60s or the 70s. But as technology changed and the architecture changed, it kind of became a less than desirable test because it only tested the front end. So today, really, up conversion radios, can we kill that bing ding dong? Does everybody hearing that, but just me?
Nope, I don't hear it.
Joining the room.
I'm sorry?
It's just people joining the room.
Oh, okay. All right. Well, well, that's good, I guess. So, except for the expensive 7851, which is an up conversion radio, most everything has changed now back to what we call down conversion or a low IF radio. Your UHF radios and VHF radios, they're really way behind performance at HF. I won't go into that in great detail today, but they're all up conversion radios except for one. So here's some numbers that we should look at and be talking about today. Close in dynamic range, and that's particularly important in CW and RTTY. The noise floor, even though I said, well, the noise floor is not a big problem because they're all good enough, but we need that number to calculate dynamic range. Reciprocal mixing, that's kind of a new term that the league invented about 2012 to mean if the phase noise of your local oscillator is noisy and that's the limit, well, we come up with this term reciprocal mixing dynamic range, and I'll show you a little graphic on that. One thing that hardly gets talked about is transmitted broadband noise, composite noise. That means phase noise and AM noise. And that's a really big deal at field day. If you've got a myriad of different transceivers that people bring, if you have a big operation, and particularly if you have two transmitters or more on the same band. So that's a big problem in some cases. Of course, we all know what splatter is on sideband, and probably all know what key clicks are. So those are the things that affect the real performance on the air. So as I mentioned, QST and Ham Radio Magazine, unfortunately it's not around anymore, but QST is, and they defined these new terms, dynamic range and noise floor, in 1975. So to test a radio, you have to feed in two very well isolated signals into the receiver. And just like when you talk about odd order distortion on transmit, and you see those type of spectrum analyzer plots in the QST, well, again, the third order is dominant when we test a radio. So that's what we're going to tune in and measure that. So we adjust the two test signals, two signal generators, and increase the level until the third order product equals the noise floor. And when is that? That's when it goes up 3 dB. So we tune away from the signal, tune into the third order product. If it goes up 3 dB on our analog RMS meter, that fits the definition. And so just as an example, if the noise floor was minus 128 dBm, and that's pretty weak, like minus 107 is 1 microvolt, just to make a frame of reference if you think in microvolts. So it's quite weak. And if the two test signals happen to be minus 28 dBm, well, then the difference between those two is 100. So that's the 100 dB magic radio, but it might be, any number. As I mentioned, the testing originally was only at 20 kilohertz, and that worked for a while. And then radios that had roofing filters came along, and it didn't become an adequate test anymore, because if the two signals are 20 kilohertz down the band or 40 kilohertz down the band with spacing of 20 kilohertz, that would then push that intermod product in the passband of your radio, and of course in the passband of the roofing filter. Then really you didn't test much except the preamp if it was on, the first mixer, and that was about it, or some passive intermod possibly in the front end. So in about 1976, maybe 75, I was noting the receiver I had tested one way on the air poorly, but in the laboratory, it tested just fine. So wait a minute, if the radio falls apart in a CW contest, yet we're testing in the lab at 20 kilohertz spacing and it says it's like 85 dB or something, well, then there's something wrong. So what I did was move the two test signals closer together, and I just picked 2 kilohertz because it was close enough it'd go through really any roofing filter at the time. And suddenly the numbers that were up in the 80s went down into the 50s. So that was what I started doing way back before we had the internet and just had a published chart. So as I mentioned, reciprocal mixing dynamic range, that has to do with the phase noise on our local oscillator. Now back when we had a Drake or a Collins or a Swan. We had a PTO. It was pretty clean. Had a band crystal, crystal for each band. That certainly had low noise. So it really wasn't an issue. But once the synthesized radios came along, like 25 or 30 years ago, well, we liked that because it was no drift, digital readout, and general coverage generally. But along came the phase noise because the oscillators were really not very good. So I found this little graphic on the internet. So look at the little bullet nose signal on the left, and that's the weak guy we're trying to work. That's going to be DXCC number 100. So we really want to work that guy. But there's a really strong signal nearby, and we're going to make it a perfect signal. Of course, that doesn't exist. But even if it was perfect, it doesn't matter because our local oscillator has noise on it of some amount. And that noise on the oscillator mixes with that strong signal that's nearby. And it can put sidebands on top of the signal like we see over on the right. Now this little graphic assumes that the phase noise of our oscillator is going to fall off fairly quickly, and maybe it does, but a lot of radios don't. Matter of fact, some are just as poor at 100 kilohertz or 200 kilohertz or 300 kilohertz. So that area where the strong signal needs to be close to the weak signal may be down the band a lot. So the phase noise was a big problem. We're lucky to say now that's really improved on some of the latest radios. So as I say, the devil's in the details. We need to really look carefully at the reviews. If you want to read Bob Allison, who's the technical director at QST at ARRL, he has sidebars on a lot of his reviews. And so here's a couple key ones. If you want to read about reciprocal mixing dynamic range, April 2012 and May 2016, you can of course go in and if you remember and log into the technical stuff and look at those issues and read Bob's sidebar. I would say for at least 20 or 25 years, most radios were actually dominated by the phase noise and not the third order dynamic range. And here's a prime example. In 2013, the FTDX 3000 project review listed the dynamic range as 100 dB, but it was measured in an unusual way in that the measuring device had a 1 or 300 hertz bandwidth because there was a lot of phase noise. And that number to me was misleading because I had actually published on my website the dynamic range of the 3000 a few months before the QST review, and I said it was 82 dB, and that kind of caused a flap because some of the magazine ads said it was 106, and I don't know where 106 came from. But anyway, the league review said it was 100, but if you read the fine print, it said the reciprocal mixing dynamic range was 82. Well, if one measurement says the limit's 100 and the other says it's 82, well, of course, it's the lower number. That's become much less of an issue with these newer designs, so it really doesn't come up too much, but it did in March of this year. There was a review of the Xiegu, I hope I'm pronouncing that right, the G90. It's a little QRP transceiver out of China. And here was a case again where the dynamic range was measured with a narrow filter, I'm assuming, and he said it was 91, but it also said the reciprocal mixing dynamic range was 84. So whatever the number is, the lower number is the one to pay attention to. And then read Bob's sidebar. As always, read Bob's sidebar. He said it had poor key clicks, the splatter and sideband wasn't too good, the transmitted noise wasn't good, and he said don't use an amplifier. So we need to be good neighbors and not pollute. I mean, obviously we want to have a nice strong signal, but we want it to be narrow and not spreading out with clicks or splatter or wideband noise. Well, in the past, the number of, we'll call legacy, meaning the super heterodyne radios that really did not have a phase noise issue were somewhat limited. So like today, the K3S is excellent. And by the way, if you have a K3 and you haven't updated the synthesizer module, I think it's gone up from $200 to $300. So it's still a good bet to significantly improve your K3. Of course, the 7851 is extremely expensive, $12,000. We'd expect that to be good, but the newest two radios that have come out in the last couple of years, the new Yaesu, the new Kenwood, absolutely amazing. one thing, the direct sampling radios from ICOM, Flex, and Apache, it's hard to goof up the phase noise on a direct sampling radio. All you need is a clean clock oscillator, and they all have a clock, and you put a good clock in it, problem solved. So really, as we keep marching on, as direct sampling becomes more and more common, this will be even less and less of an issue. So here's a break, the third way through. Do we have any questions or comments? Shoot away. I don't hear anything. Does anybody want to unmute, or are we good?
I'm looking for people to hold their hands up. And Barry, do you see anything
I have a question.
Sure.
You hearing me okay?
Yes, I do.
Okay, good. Would the 7800 perform similar to the 7851?
From a phase noise standpoint, no. That was kind of interesting. Ray Novak asked, well, no, why isn't the 7800 further up in the chart? And that was because the close-in phase noise was not excellent. It wasn't terrible. It was in the 80s. But that was the big improvement once they moved to the 7850 or the 7851, was the synthesizer improvement was dramatic. So now if you were 10 or 20 kilohertz away, the 7800 was fine, but really close in. Matter of fact, they did do an improvement when the third roofing filter came along. They did improve the phase noise a little bit because the second LO was a part of the problem. So, but still the 7800 doesn't compete with the 7851 or the Kenwood or the Yaesu.
Thank you.
I got a question from the chat. Where on your website are the rankings?
Okay, well, they're sorted top to bottom by close-in dynamic range or phase noise limited, whichever is lower. So everything that's always worst case. So if you just look on the right-hand column, it starts at 110 for the new Yaesu, and it goes down to numbers that are like in the 40s.
What's the URL?
You can go to NC0B.com, NC0B.com, and then there's a little banner that runs across the top. You can just click on that banner and it brings up the page.
Yeah, I'm going to ask people to use the method of raising your hand or put it in chat. The URL is in chat right now for those that need it.
Okay, shall we continue?
Are the slides in the Contest University books?
Well, this presentation has some things that were in 2020 Contest University, but it's been added to since then. The Contest University at the end, the last slide, and the PDF of this presentation can be made available to anyone, and it has a bunch of links, and certainly the Contest University has a lot of presentations, not only me talking at the end, but all the professors have presentations. So there's a lot of material out there.
Okay. All for the chat.
Okay. So there's really two basic types of transceivers today. The super het, of course, that's been around for a long, long time. The direct sampling, but we've got two kinds of super het now, a hybrid. What is a hybrid super het? Well, it's got a direct sampling band scope, and that includes the new Yaesu 101D and the new Kenwood 890S. The resolution is phenomenal. And you say, okay, did I really need that kind of resolution? But I'll show you in a bit why it's just amazing what you can get from a direct sampling, either hybrid radio or just a direct sampling radio compared to what we had in the past, like a Pro 3. The first radio I ever owned was with a band scope is a 781 from ICOM. Resolution was about 3 dB points, was like 800 hertz. I could resolve two signals 800 hertz apart. Now that seems like in the Stone Age. But both work and they have their strengths and their weaknesses. You know, everything has its strong points and usually a weak point. For instance, if we're on field day, we have an advantage with a radio with a roofing filter. The roofing filter, of course, kills off most of the signals on the band. It's whether it's 15 kcs wide, like in the older radios, or it's like a K3, it's got a 500 or a 2.7 kilohertz. That means all those other signals don't get through the roofing filter. So the blocking that would be important with a really close neighbor, mile away, field day, the blocking typically for a super hit can be 25 dB stronger than the overload point of the analog to digital converter, the ADC. Now, this is talking about signals that are S9 plus 60 plus. So if you've got an S9 plus 70 signal and you don't have any attenuation turned on, well, you can block a direct sampling radio. But how many times do we deal with S9 plus 70 or S9 plus 80? But of course, if you got a neighbor down the street, that might be the case. So those are the concerns for the newer style direct sampling radios from really the three major OEMs. I gotten some emails in the last, let's say, month, and they said, I've got a new ham that moved in 2 blocks away. I'm going to buy a new radio. In that case, he's probably better off with the hybrid or the direct sampling that doesn't necessarily have a special band scope. But for most of us, most of the time, it doesn't really be a problem. The other thing that is more of an issue really in Europe on 40 meters, but is what does the ADC have to look at for a direct sampling radio? Because it doesn't have a roofing filter by definition. It's got an LC filter, typically a half octave. And the half octave has been around since we first started getting the general coverage receivers. So like on 20 meters, 11 megahertz to 15 megahertz. And there's a lot of commercial stations in there. It can be quite strong. But then if, for instance, to compare the little 7300, which is a bargain, to the 7610, which costs 3 times as much, it does have a tracking preselector, as do some other radios. And so that helps particularly out of band signals. It may help in band. For instance, if you were on the East Coast working CW on the low end of 40 meters, and those broadcast stations from Europe are coming in above 7200, but the tracking preselector would probably knock them down about 10 dB. So that helps. So let's look at some of the things that are important. If you work CW and particularly contesting, maybe you use full QSK or at least semi break-in. I like semi break-in. I don't need to hear them between every letter or dit, but I want it to be clean and not a lot of clicks and pops. So I like semi break-in a lot. The audio peak filter, some of the radios have that, and it reduces noise. I don't really crank it way down to like 50 hertz or something, but it does take the edge off of noise. So that's the way I happen to run it. I really can't imagine today owning a radio or buying a new one anyway that didn't have a band scope and the waterfall. It's really useful for some things. Now, if you're just a big contester and you run 99% of the time, it may need not be as significant, but I'm a search and pounce contester, and boy, do I use it. We need a good user interface that's not clumsy. And of course, a rock solid connection to the logging program if you're, whether you're logging for a contest or just you'd like to keep a computer log. Personally, I like a knob for a computer controlled radio. And you can use a mouse, but for me, a knob works better. So let's talk about some numbers. What do they mean? And do you need the absolute highest dynamic range radio you can buy today? And I'd say not likely. But you can optimize whatever you have, run it the best way so you don't stress the radio. And we have a lot of choices today, thank goodness. So here's a listing from all 6 major OEMs that they have at least this good for their top of the line radio, which are just amazing. If we would go back to 20 years ago, we couldn't imagine these numbers. So the close-in dynamic range, 95 dB or higher. Reciprocal mixing, which you'd like to be better than the third order number simply because it can only, reciprocal mixing can occur if we only have one strong signal, where the third order type of thing requires 2 or more. So that's amazing. The ICOM series there, the Flex, any of the Flex, any of the Apache, Elecraft K3S, or upgrade your K3 with the new synthesizer, and then the two newest radios, the Kenwood TS890S and the FTDX 101D, or the MP. I haven't tested an MP, but I'm assuming it's the same. Above 6 meters, if you're into VHF and UHF, we don't have this kind of performance. So here's some transceivers off my list on the web, that NC0B.com, and then click on the banner. This is not the number 1 through 18 because there are duplicates, and I'll tell you why. You know, the K3 came out in 2008, and then they upgraded it, and then the K3S came out. I did some testing at one point between a Flex 6700 and a K3S on 10 meters. So that information is there. And then the direct sampling radios have more variation from sample to sample, each unit, because each ADC chip is slightly different as far as its minor distortion. So there's a second sample. In other words, there's 2 samples for several of the new direct sampling radios. So I didn't want to count all those twice. So these are the 18 individual transceivers that go from 110 down to 90. And you can win contests, you can work DX, you can rag shoe with any of these and not say, is my radio really going to be a limit? Not very often. I've used, of these 18 separate models, I've used 12 of them in at least one contest and sometimes more. If you are a contester and know N2IC, Steve London, he's down in New Mexico, and he has a pair of TS590s. And that's certainly a modestly priced radio today. I think the new price is $12.50 or something like that. And of course, available in the used market. That's one thing that the ICOM 7300 has done is affected the used market. So we have bargains galore because it brand new is like $1,000. So if your budget is limited, it's kind of a buyer's market today. The elephant in the room is, where is the K4 going to fit as far as performance? I'm sure they wish they had shipped more by now. I don't think any have come out. At least I haven't heard of any, but maybe October will be the month. We don't know the performance. We can make some educated guesses because we do know the architecture, and I've confirmed that with Wayne. So a straight K4 will have 1 ADC, 1 set of bandpass filters. The K4D will be more like the 7610 from ICOM. It'll have 2 ADCs and 2 sets of bandpass filters. Now, that doesn't mean you can't have 2 receivers for the straight K4, but if you were, and if they're on the same band, it's no problem. But if you were going to be running on 20 meters, let's say, or operating on 20, and you want to listen to what's happening on 15 or 6 or whatever, once you go broadband with the straight K4, the bandpass filters are going to have to go broadband. So if you're needing more front-end protection than that, well, the K4D would be a better choice that you could add to it later. It's modular. Then, of course, there's the K4HD, and that includes a superhet module that kind of mimics the K3S, and that would be the highest performance from the standpoint of the overload point. It will have roofing filters. The straight K3 or K3S, as you may know, can have 5 roofing filters in the main receiver, and if you had the second receiver, the sub receiver, you could have another 5. So you could have a total of 10 roofing filters. That always seemed a bit much for me. But the K4HD will have a sideband roofing filter and a CW roofing filter for the main receiver, and the same for the sub receiver. So you have 4, period, of end of discussion. And the architecture will be very similar to the FTDX 101D or the MP. So I'm going to guess, since most of the direct sampling radios are around 100 plus or minus a few dB, and the K3S is about 106 or 107, probably the HD will be about like that, maybe a little better, who knows, but that'll be the ballpark guess. What is a little surprising is the price differential. I added the tuner to the few that didn't have a tuner, so the K4, that's an option. The Flex 6400, that's an option, but most have a tuner built in. So to make this apples to apples, you can see in the all the other brands there, Apache, Flex, ICOM, Kenwood, and Yaesu, you know, the $3,000 range, plus or minus some, kind of the sweet spot today for a high performance, full performance radio. So the K4 is going to be more expensive, but they're going to be offering some features that don't exist in the others, like pre-distortion, which I'll cover in a bit, down the road anyway. So now, how do we make whatever radio we own work the best possible on the low bands and the high bands? It really comes down to net gain. And so what are we going to do about that? So I'm going to show you slides from a contest emphasizing how do we use our attenuator correctly? How do we use the preamp properly? If we're on 40 meters at night, and assuming we're using our transmit antenna and not some RX antenna, well, we should really be looking at using our attenuator, certainly not the preamp. But if we're on the higher bands and we are in a quiet location, well, then the preamp likely makes sense. But if we're in town, like I'm in town right now, and there's no reason for me to turn a preamp on, it's just too bloody noisy here in Denver. Okay, so here's the ARRL contest on 10 meters, December of 2018 in the afternoon. This happens to be a screenshot of the TS890S. And even though 10 meters is kind of tough, the sunspots, of course, as we know, have been poor for a while, but there were, in this case, over 20 stations in 10 kilohertz. So there was lots of activity. They were kind of weak, but there were people to work. So look in the upper right-hand corner. We've got preamp on. Oh, that makes sense. I'm out in the country there. Quiet location, preamp helps, good deal. Lower right-hand corner, I've got my audio peak filter on, as I mentioned earlier. It takes the edge off of noise, and maybe it even adds to your selectivity if you want to really crank it down. Well, here's the other December contest from the ARRL, 160 meters. That would have been the weekend before, Friday evening. And, well, you can see way more QRM and more information here than I actually expected when I took the screenshot. So let's look at some of the settings on the 7610. Over on the left, I've got the 12 dB attenuator on. And I don't know how many of you run an attenuator, but I'll tell you why. There's two reasons to do it. If you're on 160 and 80, ground wave can be very good, and most people will use some sort of a top-loaded vertical on 80 and 160. And if you're running legal limit, you've got a station even a few miles away, you can have a bodacious signal. So if there's any chance of overload, you can put in some attenuation. But really, we need to pay attention to what band noise is from 6 meters clear down to 160. Just from 10 meters to 160 meters, band noise typically in a quiet location out in the country is 30 dB different, 30 dB more noise at night on 160 than on 10 meters during the daytime. So we've got sensitivity / noise floor to burn. The other thing is there's really no reason to have,
I'll let you out.
there's no reason to have the AGC running on band noise. And we don't see too much of that on 10 meters, we hope. But on 160 would be typical, and the estimator be running way upscale. So I like to set either with the attenuator or RF gain, or with, for instance, the Flex or the Apache, they actually have a separate adjustment for AGC threshold. I want it to be above band noise. So how do you know that? So let's say we're on 160, we tune to a dead spot, we punch in our 6 dB attenuator, and I bet the noise coming out your speaker or going to your headphones doesn't change at all. But maybe if we push the 12 dB attenuator, the band noise coming out the speaker goes down a bit, and that's a good starting point. I ran a contest a couple years ago with the TS990S and the 7300. And I often use operate a contest with 2 rigs. It'd be a new one I'm trying out, comparing it to a reference radio. Well, the little ICOM only has a 20 dB pad, period. And so to make it fair, I ran the 18 dB attenuator on the Kenwood, and I ran the 20 dB on the little ICOM. So they were very similar. And actually, I'd never done that before at 18 dB, but I loved it. Now, did I have to turn the volume control up every once in a while for a weak station? Yes. But I would say like 98% of the time, the signals were above band noise. So when I was tuning in between stations, I didn't have to hear band noise as loud as the stations I was working. What I call contest fatigue or just DX fatigue, if you don't have to listen to really loud band noise hour after hour, then the fatigue factor is reduced. So there is what the main reason I took this picture was. Of course, in the upper middle, you see APF, audio peak filter, so that should be no surprise. But what else do we see here? Over here on the left, it says key clicks 5x. Now look how wide that signal is. You can see it on the band scope. It's got all those wide shoulders as it goes down towards the baseline. You can see it on the waterfall for sure. Look how wide that is. That's terrible. And then we go over to the right where it says clean. Now that signal's like 3 dB weaker, so that's insignificant. But look how nice and clean that CW signal is on the band scope and on the waterfall. It's night and day difference. And go back to the wide one with the bad key clicks. There's a little bitty signal trying to peek out from his key clicks. You can see it on the left side. You can see it on the waterfall. You can see it on the band scope. If I was trying to work that guy, I'd be having to contend with that guy's key clicks. So it's this is what we can see with the high resolution band scopes today, either with the direct sampling receivers or the hybrid that have the direct sampling band scope. So we can really tell who's got the clean signal and who does not. Here we go to sideband to make the example. Really, rigs today have not improved from the standpoint of splatter. They're not terrible, but they're not great. However, Apache right now is the only one that uses pre-distortion, which is the way to correct for distortion in the PA, in the rig, or your external amplifier, which is a sampler on the output of the external amplifier. And it feeds a signal back in that in effect's like negative feedback, inverse distortion, to reduce the splatter. So I was actually talking to the station here, KA0KA on 20 meters with the pure signal. Now he's a hi-fi guy. I don't happen to run hi-fi sideband, but he does. So he has a bandwidth that's over 4 kilohertz. But if I was talking there with the Apache, I'd set it at 2.8 or 2.6 or whatever. But the point is, look how straight up and down his signal is. There's no fuzz on the sides. Now we go down the band 14 kilohertz and there's a signal. I doubt the transceiver's that bad. He's probably overdriving his linear, but look how wide he is. He's probably 3 times as wide with his splatter than his main signal. And that's a shame because we have to share the bands. Contest University really makes a big deal of being a good neighbor. We don't want to be taking up more space than we need to. I happen to get on the air in the mornings at 8 o'clock on 75 meters with some more or less local people, Colorado and surrounding states. And there's 3 or 4 people that have this Apache with this pure signal pre-distortion written by Warren Pratt, NR0V. And it's just night and day difference if I happen to be using the Kenwood for that typical QSO roundtable. And you just look at it, it's like night and day. Either you look straight up and down on the right, or you have fuzz on the sideband. So it's just amazing. At the moment, though, we only have that from one OEM. Flex has talked about it for a long time. It's on their list. I hope I see it sometime in the future. Elecraft says they will have it. There is an input on the back of the K4 to feed this sampler port from your external amplifier into the K4. Of course, the software has to be written and the devil's in the details, but hopefully in the relatively near future, we'll have more OEMs that offer this and we can really all look like the one on the right that doesn't have any fuzz on the side. We've talked about now, what do we do on 160, 80, 40? We turn on the attenuator, so band noise isn't really so dominant running the AGC, but how do we know when to turn on the preamp? I call this antenna noise gain. We'd really like to have access to your dummy load, whether you've got a spare port on your transceiver, maybe you've got like I do, an alpha delta antenna switch. It switches between antennas, and we'll just put a dummy load on some port. And you can just do it for your test if you want. So what we do is you can listen to the noise coming out of the radio. I'll of course put a meter on it. so I can measure it in dB, but you can do it by ear. So then you switch between your dummy load and your antenna with no signal tuned in, of course. And we really want band noise to go up significantly. So here's 3 examples for each band. So I'm on 10 meters with a 5-element Yagi at 65 feet. And with no preamp on this radio, which happened to be a Pro 3, if I switch between the dummy load and the antenna, it only went up 3 dB as measured on my RMS voltmeter. Well, that means that half the noise is coming from the radio and half the noise is band noise. Well, that's not what we want. We'd really like the radio to be insignificant from a standpoint of noise. So if I turn on preamp 1, 9.5 dB. So really anything between 8 and 10 dB is wonderful. In that case, the receiver noise is insignificant compared to band noise. The band noise should really dominate. There's really likely no need to do preamp 2 on 10 meters on this radio. But if we go up to 6 meters, when I have no preamp, 1 dB antenna noise gain, I can hardly hear that and measure it with a meter, of course. But we turn on preamp 1, it only goes up 4.5 dB. That's still not enough. It's better than 3, but not much. Preamp 2, I'm almost up to 10. So that really gives you an idea. Now, if you live in the city, you may find that the preamp is really not helping. The other thing is keep your coax losses low. If you're really working on the upper bands and you do have a quiet location, I use surplus hardline. So keep your losses down, and then you can really tell the difference if you are in a quiet environment. 2/3 the way through, question time again.
I'm going to jump in again and ask you about a feature front end.
Bruce, I would like for you to either raise your hand or put the thing in the question here. We have everybody just jumping in. We're going to start doubling on everybody.
Okay, so is it Bruce's turn?
Yeah, go ahead, Bruce. I'd like to not have people do that. That becomes a problem.
Would you rather I write out the question?
Your choice, but you got the floor now. Go ahead and answer it. But let's everybody refrain from just jumping in like this. It is not fair to the other folks either. So, but go ahead and do your question there.
Right, quickly about filtering on the front end. The 101, the FTDX 101D has something called VC tune, and the ICOM radios, the high-end radios, they have something called DigiCell. And I was thinking that that feature would cut out-of-band noise. I have DigiCell on the 7800. It doesn't appear to do anything as far as what I see in band. Could you comment on that?
Well, noise as you would hear, you wouldn't really expect the LC filter that's tracking your tuning to affect your band noise level. The reason for it is to either take other signals that are some distance away, because it's not a 10-pole filter or something. It's an L and a C, or maybe the AZU is driven with a motor and the relays switch it in for the ICOM, for instance. As I mentioned, on 40 meters, if you're on the low end of 40 meters, the DigiSelect for the ICOM, or similar the VC tune for the Yaesu, will knock signals above 7250 down about 10 dB. So it's really to try to clean up out-of-band signals for the most part. Now if you were on sideband on 7195 and the broadcast station's on 7205, it isn't going to do anything. So you shouldn't really expect it to affect noise, but it'd be more of an issue potentially with the direct sampling radios, because they don't have a bandpass filter that's either a half octave or even a ham band bandwidth, for instance, like the Flex 6700 or some of the 6600, for instance. They've got it just covers the ham band itself until you go broadband. So it's really more for killing off signals that are likely outside the ham band. But they're also bandwidth affected from the standpoint of a percentage. So if you go to 10 meters, it might only knock something down a few dB 500 kilohertz away. On 40 meters, it's like 10 dB 250 kilohertz away. And on 80 meters, it's like 10 dB maybe 100 kilohertz away. So on 160, it'll have the most effect from a standpoint of how much offset that maybe an interfering signal has, where on 10 meters, almost nothing. So don't expect it to do anything about band noise. I'm a little puzzled by the way that you can use the VC tune, because you can tune it and you can actually tune the DigiSelect manually. I don't see the point because they're not that sharp, but there's a feature there. And if it does something for you, fine. I've seen some email posts that said, oh, it reduces noise. In that case, I'd wonder if it's not insertion loss. So it's helpful, but I don't know that we'll find much in band too useful. Certainly here in Colorado, not. If on the East Coast with Europeans coming in, maybe a different story. And certainly if you're in Europe on 40 meters, probably it may be real significant.
Thank you.
Chat rooms, please.
You want to do the hand, Dan?
We still have some pending in the chat rooms.
Yes, I know. I'm just wondering if someone has their hand up. I want to see if Dan wants
Yeah,
to.
go ahead. I was muted, didn't realize it. Yeah, we have a hand up by Mike in California. You want to go ahead and do it? And Barry, there's a question up a little farther in the chat thing we need to catch.
I got that one.
Okay, Mike.
First off, thanks for the presentation. I got a question about hardline, and you know, I'm a fairly new ham, and I'm usually running and operating around 75 to 20 meters. When I get in the higher bands, it gets pretty quiet. And I'm wondering, the line I'm using now is an RG8X, and it's running out about 100 feet before the antenna. So am I very compromised at the higher bands using that cable?
Okay, well, I have a 150-foot piece of LMR 240, which is kind of like RG8X, and I bought that for a field day. It's 150 feet long, and it has about 2 dB loss on 20 meters. And I didn't see the need to buy the LMR 400, pick up 1 dB and spend 3 times as much. One thing to note that I have 6 towers at my QTH. 4 of them are 200 to 350 feet away from my house, and the neighbors are thousands of feet away. And now I have 2 towers that are close to the house, one by the garage and one by our master bedroom. And it's amazing how much more noise I pick up from my house, and I haven't gone search and destroy to find what kind of equipment's making racket, but you know, all these power supplies and things like that I mentioned. So my runs are longer than yours. So I've got a 270-foot piece of hard line to go out to the most of the towers, and believe it or not, because the 10-meter tower for the 10-meter Geigy went up last, it's 350 feet away, and it has 500 feet of hard line. So obviously that's a much more big deal. If you're on 20 meters and below and you've got 100 feet of coax, I'd probably rather use RG8 or LMR 400. The nice thing about hardline, if you can particularly get it surplus, is rodents probably can't chew on it very much, and just damage can get a pinhole hole in the jacket, and then moisture gets in there, and moisture is really deathly to coax. So I'm a hardline fan, but from a loss standpoint, if you're 100 feet or less, on at least up through 20 meters, not a big deal. If 6 meters, I'd say yes. And here's what Tim Duffy's K3LR's rule is. He doesn't want any more than 1 dB of loss. So guess what? On his 10-meter tower, he's got like 1 5/8 heliacs. So he goes crazy. But it'd be nice to say 1 dB. On my 10-meter tower, I've got 2 dB loss, and I live with it.
Okay, thank you very much.
Sure.
Okay,
Yeah,
it was one before. How do you get in the queue to be tested, like a Sun SDR2?
Oh, well, for the most part, somebody loans me a radio. I don't take anything direct from an OEM anymore because I want a random sample. Kenwood does it really well. They let me go to Denver Ham Radio Outlet, and pick a random box off the shelf. And then I get to test it. And then when I'm done, I give it back to them. There'll be a ham loaning me a K4. There was a ham loaning me the FTDX 101D out of New York. I actually had the MB1, which I think isn't that the same company as you just mentioned. That transceiver, unfortunately, was early on in the production cycle, and there were just a myriad of problems, and it broke the day before a contest, so I never ended up really spending any time on that. I don't test every dongle SDR that comes down the pike, you know, like an SDR Play or something. They're kind of, I mean, they're a cute little product for not much money, and you can make a nice band scope out of it for a TS590 or something like that. I am going to be testing a little QRP radio. It's coming out of Russia. That's a gentleman's going to get real soon, and he'll loan it to me for a couple of weeks. So it sort of depends on whether it's going to be something of general interest. If it's just kind of a niche product, I really don't. It takes days to go through it and to double check everything. So I don't just text everything that comes down the pike. But of course, what's coming new? K4, IC705. And so those things, of course, get in the queue.
Okay, that sounds good. Okay, now for pure signal, does using it improve your own signal's SNR as well as avoiding others on the band?
You mean on receive?
It's what I'm asking about, yes.
No, it doesn't do anything on receive. Warren NR0V has written some pretty amazing noise reduction programs, particularly what's called spectral noise blanker. Often you'll find in a pileup or a contest that the noise blanker, a noise blanker is gets false triggered and just causes more trouble than it can probably help. But his spectral noise blanker just listens to the bandwidth you chose. So if it was 2.4 or 500 hertz, it figures out what the noise is and fills in an approximation of what the signal should have been. But the pure signal pre-distortion is simply, call it inverse distortion. So it measures the linearity of the PA in the rig, or if it's got a sampler on the output of the linear, and all the new linears have a sampler built in that have come out in the last few years, so you don't even have to buy one. And then it feeds it back in, does this inverse distortion, and cleans up the transmit signal only, but it doesn't have anything to do with receive.
Okay, and someone says, I used an ICOM 7300 this past weekend in the CQ Worldwide RIDI contest, running AFSK, and found even with the filters, the radio had difficulty with intermod from adjacent strong signals.
You know what band he was on, and was he optimizing his net gain properly? I've only had one example of running a 7300. Of course, it was out in the Colorado Plains in the middle of nowhere, where I was on 10 meters in the Able Arrow contest. I was on CW, I had preamp 2 on, and a trucker drove by. Highway 14 is about 700 feet from my tower, and I was pointed towards the Caribbean, so the road was where the bore center on the beam was about 1,000 feet away. I'm guessing it was a CB'er. I'm guessing the trucker was running more than 5 watts, and it blinked the overload light for about 20 seconds. I didn't hear anything. So if in the RIDI contest he was getting distortion, well, then he should have backed off the RF gain. We need to know, was the OVF, the overload light, flickering? If it was, well, he certainly needed to back off the RF gain or just turn on the 20 dB attenuator if he was on the lower band. So we need to know it a little bit more. I haven't seen that as an issue, but every direct sampling radio can be overloaded. And the dynamic range of the 7300 is about the same as the 7610, which is about the same as the other brands of direct sampling radios. They're around 100 dB radios. A little less, maybe 90 to 100. So usually that's adequate. So it's interesting to see that he had the problem. So if you could put him in touch with me, I'd love to get more details.
Okay, sounds good. Okay, a couple of more and then we'll go to the hands. For the new K4 line, why would you want a super heterodyne versus direct sampling system? Because of the band filtering.
No, it would be because of the roofing filter.
Okay.
So now where I am, in the plains of Colorado, it would be no point. But it would be for field day if you had a really big field day operation. You had a CW station, an FT8 station, and a sideband station all in the same band. Anytime a field day operation has multiple transmitters, hopefully they've got bandpass filters for 40 and 20 and 15, but those don't help if you got 2 or 3 stations on the same band. So if you're in a really bad RF environment, you've got a neighbor, ham, say it's a mile away, well then the extra 25 dB from an overload standpoint, I'd go with the HD or the 101D or the 890S as an example. But in the case of the K3, the K4, I don't know when that module will ship. It might be down the road a year or two. I have no idea. Don't even know what the cost is. But if you're in a really tough RF environment, you get 25 dB more protection from overload.
Okay, here's an interesting question. What is the best way to set the RF gain?
If you're not going to use your attenuator, just do the same thing as far as on the lower bands, setting band noise so that it's not running the AGC. You don't want you want the AGC threshold to be at least 6 dB above band noise. Now you can just do that by ear, like, okay, 6 dB is pretty noticeable, 3 dB less, 1 dB you'd never notice. So if you're just going to use the RF gain, which is fine, I like to know what it is. So like in the case of the 7610, you can do it in 3 dB steps. Most radios 6 dB steps, but that's adequate. But if you're happy just backing off the RF gain on the lower bands till band noise drops a little bit, that's fine.
Okay, and one more from the queue, and then we can go to the hands. How does the Yaesu FT950 fit into this mix of all the radios?
The FT950, I'd have to look that one up. I don't remember.
Okay, well, we can...
But one thing we do know, until the 101D came along, Yaesu was notorious for bad transmitted phase noise and poor reciprocal mixing in general. So I don't know that one off the top of my head, but that would probably be the limits.
Okay, Dan, I'll leave it back to you. You can do the hands.
Okay, that's good. Larry, in California, you want to take it away, ask your question.
Yeah, I was just wondering if you were talking about getting noise via your coax. How about if you ran your coax through a conduit, non-rigid conduit, and ground to that? Would that help eliminate some of your noises?
Well, I'm not sure. I didn't intend to say anything to imply that I was getting noise in my coax, although of course regular coax doesn't have 100% shield. So unlike hardline. So I would assume that good quality coax would have about 90 to 95% shield. I don't think I'd bother to run it in conduit because of that, but it's having the jacket penetrated at some time. I mean, like the coax on this tower here in Denver has been up there, I'm really embarrassed to say, since 1972. It probably should be thrown away. So the hard line will last longer and less likely a bird can poke a hole in it or a squirrel chew on it. But from a noise standpoint, common mode noise is an issue. And then we need to talk about choke balance, which is a whole different subject. And you might want to get a guest who really talks about choke balance and current balance and things like that from a noise standpoint.
Okay, let's, Iron, the KV3TB, go ahead.
Yeah, let me just unmute for a second. Bob, excellent presentation, and thank you very much. I'm the one that asked the question about the 7300. And no, I was very cognizant the overflow light wasn't coming on. And the distortion I was on, normally I run a K3S in a contest for a RIDI contest, and I'm able to filter out a lot, especially the inner mod coming from adjacent strong signals. And this is the first time I've used a direct sampling radio. I just happened to be at my vacation home by the Delaware shore, and I have a 7300 here, and I said, well, let me play around with a contest this weekend. And I found that this direct sampling radio had a lot of difficulty when two adjacent stations were very close by and the ability to differentiate them to pick up the RTTY signal. And it just may be something that I have set wrong on the radio at that point. And I'll take it off and go back to mute. And thank you very much.
Sure. Well, what band was it?
Both 20 and 40 meters.
Okay.
Primarily 40 meters is the worst.
Did you try the attenuator on 40?
No, I did not. And maybe that's what I need to do next.
And or did you back off the RF gain a little bit?
Normally I'll back off the RF gain a little bit, but sometimes the signals are just so strong. You know how the RTTY contest going, especially in AFSK, they can be very strong, even coming out of Europe.
Oh yeah, oh yeah. Well, the next contest, just play around a bit more, and be interesting to hear your feedback. Drop me an email. I mean, obviously, we don't expect $1,000 radio to have to be like a $10,000 radio, but I'm a little surprised. But that's good feedback. I mean, we need to know what. I wish that ICOM had put a 10 dB attenuator and the 20. That would have been nice.
Totally agree, and thank you. Now I'm going to try the CW contest coming up. I'm going to use I've got a new Flex 6500 that I picked up from Flex. I'm going to try that. That'll be my next entry into these direct sampling radios.
There's one thing that's different about the Flex, in that you can actually take the preamp out of the circuit, electrically out of the circuit with relays, where like the Apache, there's a preamp there all the time, but then an attenuator, a variable attenuator. So different concept. And of course, if you can actually just take the preamp out of the circuit on 40, 80, and 160, it sounds like a good idea.
Great, we'll give it a try. Thank you.
Sure.
Okay, I think that we're looking good right now, unless, Barry, you see anything more?
Nothing more in the chat.
All righty.
Okay, on we go. So now we're going to see what techie nerds do with spectrum analyzers and why we really need to think about how clean our transmitter is. You can see pictures like this in QST. Get a drink of water, it's a minute. You see pictures in QST, something like this. So when we test transmit intermod, we feed in two signals that are the same level. And then with your spectrum analyzer, it's real simple. You have two cursors, and you put one cursor on one of the two signals. They're equal, so it doesn't matter which one. And then you can put it on third order, fifth order, seventh order, ninth order, etc. So you can see right on the display here that the third order was down 36.5 dBc. That's not the way the magazines published distortion. They added 6 dB. Makes you feel good. Instead of being 36.5, it's going to be 42.5. But guess what? It doesn't change anything but the number. But this is the cleanest transmitter I've ever owned. I think it's out of production. So unfortunately, we've gone downhill from the Collins 32S3. And also we note the the fifth order is down 47 dBc, or add 6 dB to that, 53. So this is a really clean transmitter. The other thing to note is this spectrum is plus or minus 20 kilohertz. And this is showing an 80 dB range of signals, 80 dB range of distortion. So it's all gone by plus or minus 10. There's the second cleanest transmitter I've ever owned. That was the TS990S. Unfortunately, a nearby lightning strike and the EMP took it out. But it has a 50 volt PA. And in general, I think the 50 volt PAs are about 5 or 6 dB cleaner than the average 13.8 volt PA. Well, the third order was only 2.5 dB worse than the Collins. But as you see, it doesn't fall off nearly as quickly. If you go back to there, you see plus or minus 10. Here, plus or minus 18, something like that. So we've got more splatter, sort of typical of today. Here's the K3. Well, it's about 9 dB worse for third order than the Collins, but it's at plus or minus 20 kilohertz. It's still going and hasn't even faded out yet. So we'd really like the solid state PAs to be better. Other than pure signal, there's not a lot we can do about it. But this is the reason that I always say, when we're looking at my table and it's sorted by close-in dynamic range, that's really a CW issue, RTTY issue, not so much sideband. Why is that? Well, if this was our typical transmitter and the distortion at 4 kilohertz away, and we'd hope we could work a weak guy 4 kilohertz away from a strong one, but if the distortion products are down 45 dB, if this was a TS590SG, for instance, it's trying to listen through the splatter, its dynamic range is 92 dB. The typical up conversion radio that we had from like the TR7 through the Pro 3, for instance, and all for that 20 or 25 years of up conversion radios, dynamic range was about 70. Well, if the splatter is down 45 dB and the radio is rated at 70, the splatter dominates. But on CW, thank goodness, we don't have signals that wide. And so this is why the sideband operator, contester, DXer could live with the up conversion radios that were really only 70 dB, 70 plus or minus 5, let's say. Because on sideband, the guy 3, 4, 5 kilohertz away, his splatter really dominated. As you saw with that pure signal example and the guy who was wide, I'm guessing he was overdriving his linear. I use a sampler on the output of my amplifiers and feed a scope. And so I know I'm not clipping. On CW, let's see what's is our limit on CW. Well, this is, if you just put a rock on the key, your signal is really narrow on CW. I don't know what it is, might be 100 hertz. But once we start sending information like 599, Colorado, well, then we have keying sidebands that produce key clicks. But it's very dependent on the rise time that we select today in a menu. Unfortunately, almost all the OEMs let you pick terrible rise times. So if we look at this plot of the key clicks on with a 1 millisecond rise time, that's the top graph, and we compare it to 6, which is really what you should pick, the key clicks are 25 dB worse 1 kilohertz away. Now you'd hope you could work a weak station 1 kilohertz away from a strong guy, but if he's turned his rise time to 1 or 2 milliseconds, he's going to have terrible key clicks. I don't think the OEM should let you even do that. Elecraft with the K3 and the K4 will not let you do it. I think they pick 5, so that's their choice. That's okay. But they will not let you pick 1 or 2. It really should have a big warning. Dial in 1 millisecond, out to pop up on the screen and say, terrible key clicks, do you really want to do that? But it doesn't. So go into your menu if you've got a radio that lets that be adjusted and pick something 6 or thereabouts. Transmit composite noise, it's really mostly a problem for in your local area, hams close by, field day. And so there's really a wide difference. The K3S is really probably the best. At 10 kilohertz, it's down a massive amount, 141 dB. And at 100 kilohertz, it doesn't get much better because it was outstanding at 10. We look at the ICOM 7610. Well, it's not near as good at 10, 128, but it's virtually identical to the K3S at 100. So that's a big deal if you were like on field day and you're on CW or sideband and the other station's 100 kilohertz away. Well, the K3S and the 7610 to do fine. Now we look at the Yaesu FTDX 3000. Well, it's not good at 10, and it doesn't get any better at 100 or 200 or 300. So that'd be a terrible choice if you've got a neighbor. So I've got a real life example. In Boulder, Colorado, there's a ham up on the foothills. So he's at about 7,000 or 8,000 feet, I think 7,000. He's overlooking the entire city of Boulder. He used to have an FT 1000 MP, and he never caused any problems. And he happens to like 15 meters, and a friend of mine also likes 15 meters, and they didn't bother each other. But then he got an FTDX 3000, and his transmitted noise on 15, line of sight, it's 5 miles away because he's up on the mountain, S9 noise, virtually wipes out 15 meters. So here's a case where Yaesu's done an outstanding job with the new 101D in comparison to some of the older radios. I don't know how many of you read my article in November last year, QST, the title was "It's Time to Clean Up Our Transmitters," and that was the title the league put on it. And I really want to compliment the league. We were talking about something that really is pointed at all our original equipment manufacturers. The receivers are outstanding now, but transmitters have not improved. And in comparison of the Collins to current day product, it got worse from the standpoint of sideband. Or if we had our key clicks terrible because we picked a terrible menu choice. It was interesting that in the same issue, they tested the Expert 1.5K FA amplifier. It was a typical LD MOS minus 30 PEP. If we measured it with the spectrum analyzer, it'd be minus 24, but we'll just go with the PEP method. I call it the feel-good method, but that's what we have. But they did pure signal. It improved 17 dB for third order. So that's what I wish we all had that. I don't own a rig that does it, but I wish I did have that kind of clean signal. So let's look at linear amps, and I use the word linear kind of with quotes. The ARRL published a compendium of tube type amplifiers in 1997, no surprise, tubes. And all those amps had third order products down 40 to 50 dB using the PEP method. QST has reviewed the KPA 1500 from Elecraft, IMD's minus 30 PEP. That's 10 or 20 dB worse than the better tube amps. Power Genius hasn't been in QST yet, but it's been tested here in Colorado. 20 meters, minus 30. 3 dB worse on 10 and 6. The Expert 1.5K, that was in QST, minus 30. So this is pretty typical of LD MOS. We like the LD MOS because apparently they're somewhat more robust from blowing them up with bad SWR or something, but they haven't been an answer for cleaning up solid state amps, aside from pre-distortion, if we can get that to be more ubiquitous. The TS990S, that was the 50 volt PA, that's 10 dB better than these PAs, than these linear amplifiers. So we'll have a nice cleaner signal with the 990S, and we run it through a typical legal limit amp, and poof, we're 10 dB worse, and that's too bad. Recently, the league has started publishing an input-output curve for the amplifiers they're testing, and this is great. On the left is the Elecraft KPA 1500. In this case, the 20 meter graph is blue. It's not perfectly straight. It's starting to compress a little bit above a kilowatt, but it's fairly straight. Then we just saw in July an ACOM 1200S, that's a solid state linear amplifier. We'll look at the red one. For some reason they changed the color, but the red one's 20 meters. It's pretty darn straight, up to about 700 watts, and then it goes to heck. If I had that amp, I would only run it at half power because I don't want to splatter. But we can look at their numbers right out of QST. And here's the red flag. And you will see this with just exciters, transmitter measurements. If the third order is equal to the fifth order or better than the fifth order, which is not classic, we know pretty much that number is kind of meaningless, and we ought to just pay attention to the fact that it's in compression. So they did publish the data at 500 watts versus a kilowatt. Well, that's looking normal. Minus 33 at third order, and it gets better at fifth order. So that makes sense. So this amplifier at half power would be just fine in comparison to the SPE, the KPA, or the Power Genius XL. Actually, just a teeny bit better than those two, but that's at a kilowatt and a half. So this graph, we really hope that QST keeps doing that, but it's unfortunate that the this ACOM, it really flat tops. So the bottom line today, receiver performance from all 6 major OEMs is quite amazing. In a pileup, whether it's a contest or a DX pileup or whatever it is, I just use the term noise, whether it's splatter noise, key click noise, broadband composite noise. That's often the limit, not our receiver. And if the transmitters would improve, or we all learn that we don't pick 1 or 2 milliseconds in a rise time on CW, that'd be great. That's the presentation. Here's some links. Contest University videos, lots of stuff there. You can go watch anytime. And then I do some sort of stream of consciousness comments when I do a contest that I've had 2 different radios at the same time. And I send these off to my friend Rick, DJ0IP, and he publishes these things he calls shootouts. So there's the link, or you can just, search on Google, put Sherwood DJ0IP shootout, and you'll find them. So there's some comparisons, like between the 7300 and the 990, and I think the 7610 and something else. So anyway, there's some comparisons that are just more wordy than what's on the website. So we're finished up. Questions again?
I don't see any hands up right now. So Barry, is there questions? Hello, Barry.
Chat right now.
Okay. There's one here from Alex, KU1CW. Have you tested the PA performance literally from 13 volts versus 15.5 volts?
Yes, I have one in specific that I did due to people on the Elecraft reflector, the groups.io, wanted to know how much difference there is on splatter, on sideband, between the rated range, which is typically plus or minus 15%. So on the low side, that's like 11.7. On the high end, that's like 15.7. And the difference was 10 dB with a K3S. No, a K3, it was just a K3, but with an updated PA because the original PA had a problem. I'm going to do the same thing with a couple of the ICOMs. I know I did a little bit of a test a long time ago on the Flex 6700, and every half a volt going up improved the distortion by about 1 dB. So almost, I haven't seen any yet where more voltage was worse. They're always been better. Definitely on the low side, if we're running on battery, like on field day or running portable or whatever, they really go bad when you go below 13.8. So maybe that's a case where these voltage, battery voltage increasers, that even if their battery gets down to 12.5 volts, it gives you 13.8 out. That would be helpful. So there's been some discussions that unfortunately some people have not been happy with, but I've been posting on a couple of the reflectors that voltage drop in your power cord is a problem. We almost never, if you don't adjust your power supply to put out like 14.5 volts or something, to get 13.8 to the rig. And then a couple guys have said, well, they've got a rig runner, which is kind of a nice universal thing that lets you plug in a bunch of different accessories to 13.8, but they have voltage drop. Fuses have voltage drop, and sometimes the fuse holder, that's not a particularly expensive fuse holder, has voltage drop over time. It gets a little bit of oxidation there. Personally, I cut my long cords in half. I'm using Astron RS35Ms that have over voltage, over current, short circuit protection. The ICOM power supplies don't even have fuses. So if the power supply can handle a fault, I don't use fuses. And I shorten my cords by about half. If they're 12 feet long, I make them 6 feet long. So that'll help. But I also adjust my power supplies to about 14.5 volts. Makes a difference.
Okay, is there any other questions out there? I don't see hands raised. Barry, do you see some hands being raised?
Nope, don't see any hands at all, and nothing in the chat.
Okie doke. Well,
Thank you.
having a good evening, and hope you enjoyed the presentation.
Okay, I will be sending out, Rob's already sent me the presentation, so I'll be sending that out when I send out the links to the video tonight in the chat thing. Rob, I really appreciate what you did. It's a great, great presentation. Sorry for some of the interruptions there.
Oscar has a question.
Say again, Barry.
Oscar raised his hand.
Oh,
Rob, it has been an amazing presentation. All the information collection that you have done as your experience and what you have said. The whole information is really outstanding. This is, I would say, one of the best I ever seen in talking about radio performance and so on. So I does recommend it, and it's amazing. Thank you very much for your effort.
Well, thank you for the compliment.
it sounds like you got quite an antenna farm there also. Can you give us a brief description of your antenna farm?
Sure, we can see it on qrz.com. So go look at NC0B. I've got 6 towers and 9 HF monoband Yagis, and then some wire antennas, of course, for the lower bands. I work 630 meters through 70 centimeters. So I've got, besides the 9 HF Yagis, I've got monoband Yagis on 2 and 70 centimeters. I'm sort of a monoband nut. When I was in high school, I had a monoband 10-meter beam back in the 60s, and I just never did anything else. Obviously, nothing wrong with all the other antennas that have traps or multiple Yagis on the same boom, but that's what I did. What I found wasn't planned this way, but as the antenna farm grew, I have 2 beams on 20, 2 beams on 15, and 2 beams on 10. And that worked out to be really handy in a contest because I could point the 3-element beams to the Caribbean and then the 4 and 5-element beams at Europe or JA or wherever, and I just click a switch and I can go back and forth between listening and working somebody in the Caribbean or working the other direction. So it made it easier for me as a mostly search and pounce operator to be able to just point in the other direction. So I've got 10 acres out there in the plains, and I'm there for 3 or 4 days a week. And I'm glad I did it when I was 60 and not 73 as I am now.
Well, Rob, I think we're both about the same age, and there's a bunch of others out there in the same ballpark there. We have all these fun memories of some of the antennas we've had or haven't had or wish we had or got to use. That's quite an antenna farm, and your presentation was excellent. Are there anybody else that's got questions or like to make comments? We'll open it up at this point.
Just one more comment about wire antennas. Besides the 40-meter beam that I have an extended double ZEP on 40 meters, which I use on 80. So that's my only 80-meter antenna. And then on 160, I have a Marconi T. That's a 150-foot flat top and a 60-foot vertical downlead, and then a good ground system. And I use that Marconi T on 630 meters. And I've worked VK4YB 3 times in Australia on 630 meters. So it's a pretty good antenna on 630 and on 160.
Yes, yes. Your rig is about as good as your antenna, so it sounds good. All
Rob,
right.
can I ask a question?
Sure.
Clearly, the antenna is critical to match to the transmitter. How much importance is the antenna on the receiving end? Obviously, the better the antenna, the better you're going to receive, but it's not as critical as the transmit side, but could you address that a little bit?
I would say it's equally critical. I mean, a 3, 4, 5-element Yagi has amazing side and rear rejection. So it reduces the QRM, let's just say 20 dB. So if I'm flicking back and forth between a 3-element 20-meter beam pointed to the Caribbean and a 4-element 20-meter beam pointed to Europe or JA or wherever it happens to be at the time, when I flick back and forth, it's almost like 2 different bands. I mean, it literally saves signals go from S9 to S3. So I would say importance for where do we want to do our best at optimizing? Well, we live where we live, but of course the location is important, and I moved out in the country. The antenna, I would say, is second importance. And operator scale, so you can say, okay, operator scale antennas may be the same if you're talking about a DXer or a contester. The radios are so amazing today that we've got a lot of choices, but the difference on receive with a a 3-element Yagi at 40 feet versus 70 is about an S unit most of the time, sometimes 2 S units. And the reduction in QRM is just astounding when you can really switch between them instantly. It's just amazing.
All right, thank you for that. This is great information for all of us, regardless of where we stand with our shacks and future and our stuff. This has been a very learning experience. Okay, open it up one more time for anybody anywhere. Jump in there. Got any questions or comments? Well, hearing nothing, I'm going to suggest that we shut this down for the night. Ready for another presentation tomorrow, different type. So one more time, I'll ask if there's any suggestions or comments or whatever, and if there's none, we'll shut her down.
N6VI with a fast question, I think.
Okay, Marty, go ahead.
Hey, Rob, thank you. If you have something like one of the SPE amps, I happen to have the 1.3 because I kind of loaded, toted it around in carry-on luggage. If by reducing the drive power from, say, the nominal 15 watts to 12 or 13 with a only minor reduction in power output, will that improve the spectral output?
Well, first off, what's your exciter?
K3 with the upgraded synth.
Okay, the K3 is kind of an anomaly. Up through 12 watts, you're only using the driver. And at 13 watts, you're using the PA, and then the driver really loafs. The distortion at 12 watts on a K3 is awful. At 13 watts, it gets better. And really the sweet spot's kind of 35 watts coming out of the K3. As far as its distortion, you saw a K3 there that looked pretty awful, but it's significantly better at 35 watts. If you have the option to, with your amplifier, to somehow put, if your SPE only takes, what you're saying, 15 watts of driver or less?
Yeah, 15, 16 watts.
Oh, wow. You wonder if that passes the 15 dB rule, which is nuts. But anyway, if there's some way you could put a pad in there so you could run your K3 at 35 watts, that would make a difference. You do not want to run your K3 at 12, that's for sure.
Okay. Good.
Most rigs don't do that. So in general, like if you looked at the curve there on the KPA 1500, if you probably ran it a kilowatt instead of 1500, it would improve a little bit, but nothing really dramatic.
Okay,
and K1VR.
All right, thanks, Marty. There's another person that jumped in there with a question.
K1VR.
Okay, go for it.
Rob Fred, K1VR. I'm wondering if one of these days you might prepare a slide on the question you've just been addressing with Marty, and that is how to set the audio train so that you don't make such a mess on a crowded phone band.
Well, probably the first thing is to monitor your linear, number one. As far as, I don't think most of our rigs splatter much with variation on compression. I think that's probably handled fairly well. But one thing I think we need to emphasize is EQ. The newer rigs have EQ. I happen to like the simple EQ in the ICOM. It's either bass up or down, treble up or down. But like the Kenwood, it's got 20, 30, whatever, different sliders. That's kind of overkill. But what I like to see when I transmit is a fairly flat pass band in my transmit spectra. Now, what you see on your rig is not what is coming out the PA, unfortunately. But at least from a tonal standpoint and the EQ, it is accurate. So if I set my span for like plus or minus 10 or plus or minus 5 on my band scope that's one of these direct sampling, either direct sampling band scope or a direct sampling radio, that's going to show me exactly what the contour is of my voice. So I like it pretty flat. So I usually cut the bass, bring the treble up so it's more or less flat. It's going to have dips in it, of course, because we don't transmit white noise, but that will help. And then in general, keep the ALC under control. With a Yaesu, absolutely keep it under control. When I had an FT DX5000D on loan from W1STT. I found if I ran Class A, because that rig would run Class A, no ALC at all, and almost no compression, the signal was phenomenally clean. And I actually was on the air talking to a friend. A guy broke in and said, I want to comment on your signal. And I thought, uh-oh. He said, I'm looking at you on a P3, on a K3. He says, you have the cleanest signal I've ever seen on the air. Now that was pre-distortion, obviously, and it was Class A. But that was, in the case of the Yaesu, if you hit the ALC at all, poof, you might as well not even run Class A. So keep your ALC under control. Don't go crazy on compression, and EQ it right. And monitor your linear. If you're running your linear, get a scope. You can buy a scope at a Hamfest for $100. Get a sampler. Just go on the, go do a Google search on sampler. Matter of fact, KA1K, KA0KA, KA0KA sells a sampler if you don't want to build your own.
Thanks, Rob. Thank you.
Question?
Really, really great information here. Go ahead, Clay.
Yeah, this is Clay W0LED. Thank you, Rob, for this great presentation. Excuse me, it's a little hard talking with the cheeseburger in my mouth, but I use a 7300 and sometimes a 7610 to drive an SB221. And you know, they're designed to, the amplifiers are designed to be driven by 100 watts, but what's the implication when I want to not drive to the full limit of the amplifier, but back it off some?
Well, you've got an output power adjustment on the 7300 and the 7610 and just back it off. Leave everything else the same.
Okay, cool.
Can you make a comment on comparing the two on receive? Have you done ABs? I mean, I own them both too and have used it, but I'm always interested in someone else who has two rigs, whether they're the same brand or other brands.
I have found that the two behave, in terms of receive, that they behave very much alike. The only real difference is you got two receivers in one, and the other one, you know, obviously you got one receiver. But from a performance standpoint, I find that the two behave very, very much alike.
That's what I find. And of course, the 7610 has the audio peak filter, is solid state switching, so there's no relays making noise, particularly if you can key your amp with a FET instead of keying with a relay, so they're silent. You know, obviously the second receiver is obvious, but and the RX input for an RX receive antenna. So, but you're right, at least from my experience too, they seem, I've run the 7300 at least 6 times in major contests on mostly 160 and some 10 meters.
Thank you.
We're getting more questions opening this up. We were the other way. Is there anybody else out there? Okay, we'll holler one more time. Okay, Marty, did you have something more?
Not I.
Okay, you just popped up here, so. Okay, I'm trying to look here. No, okay, I don't see any more questions anywhere. This has gone quite a while, but it's been very, very good. Thank you, Rob. It's been excellent. Okay, Dale, go ahead.
Sorry, I didn't know how to raise my hand, so I just did it the old-fashioned way. Could he comment on, so I have a Flex 6600 and also an IC 7300. Could he comment on the insertion losses of the 7-pole filter, in-band filter on the 6600 and what that does to setting RF gain and AGC?
Sure. That's an unusual radio. The 7-pole filters are for the contest bands only, so they're not the work bands. And they have about 7, 8, 9 dB insertion loss, which is a lot. So if you look on my website, you'll see the noise floor with the preamp off is pretty high. But of course, you've got 2 preamps. Now, I don't particularly use the intermediate 8 dB attenuator, so let's just talk about no preamp, 16 dB preamp, 32 dB preamp with 2 in series. So if you compare the 6700 with 20 dB of preamp to the 6600 with 32 dB of preamp, they have the same noise floor. So that just shows you how much loss is in the filters. I'm guessing that they must be using small surface mount inductors as opposed to if you had a big inductor, toroidal inductor, that insertion loss wouldn't be anywhere near that much. I was surprised at that, but they make it up with the preamps, but it seemed like a lot of loss. But that shows you have to go from 20 dB on the 6700 to 32 to have the same noise floor in 10 meters.
Okay, Barry, there's somebody just popped in a question on chat. You want to catch it?
Sure, okay. Are you doing any testing, PW1, and any outlook on the PW2 amps?
I don't have any data on that, but I'm just starting to test amplifiers, and actually N0QO has a fancier spectrum analyzer than I do. He also has a 2000 watt bird attenuator. I only have a 500 watt bird attenuator, and we need a big power attenuator to test amplifiers at legal limit. So we've got about half a dozen amps right now. We're going to start adding to it, and also continue to test the transmitters, and probably come up with a separate web page on my website with amplifier data and transmit data. I would like to have access to the PW1 and the PW2. I haven't seen, I used to own a 4KL, and the 4KL wasn't particularly good. It was about an S unit worse at 5 kilohertz than my Para 3500Zs. But I can't comment on the PW1, but if Ray Novak wanted to loan me the PW1 and the PW2, we'd be glad to run them through the lab at Ken's place, because like I say, he's got the power attenuator and I don't, but we work together hand in glove, and also are kind of see if we agree on things, and we don't want to make a mistake, and it's sort of a good check to have another set of eyes on things.
All right. Yes, 2 heads are always better than 1.
Sanity check. That was the word I was reaching for, a sanity check.
There you go. There you go. Okay.
Anybody that's in this hobby, their sanity is in question.
This would be true. This would be true. All right, ladies and gentlemen, unless we got some more comments, questions. I don't see anything. There's one from Barry. You want to catch the one that just came up with the ADC?
I didn't see that one.
Yeah, he just popped in. Oh, I'm sorry. He sent it privately. That's why. ADC/DAC time delay. Is it worth measuring?
Oh, it is. I mean, latency in the radio exists, and it's affected by the design of the digital filters. For instance, when the 6700 shipped and the software back in that vintage, the delay was like 170 milliseconds, which is pretty long. A typical analog radio is about 5 milliseconds. And there's a whole bunch of data on delay. And now, of course, if you're chit-chatting on sideband, even on Vox, it probably doesn't matter much. But if you're doing even semi-break-in in a contest and you're a fast operator, delays of 100 or 200 milliseconds is a lot. Now with the new Flex, they have the option of changing the shape factor of the filter, which makes the latency less, but it doesn't have as sharp a filter. The filters in the Apache aren't designed the same way, so the latency can be in the 20, 30, 40 millisecond range. I'm going to give you a web link here. Let me double check it here. If I could type, it'd help. So if you go to NC0B.com, all lowercase, /latency, there's a PDF up there that lists the latency of a whole bunch of radios. And you can see the extent. And then, of course, those of us who have ever run remote, you got the latency and the internet. So things can add up, but it's not trivial. I don't say it's the end of the world, but I'd rather be 50 than 100. I'd rather be 100 than 170.
All right, great. Anybody else? This is why I like Zoom over webinars and YouTubes. I like this interaction. Okay, ladies and gentlemen, okay, so let me just put that in there. Thank you very much. Is there anything else? Questions, answers, comments?
Ready for comment.
Okay, we're going to shut this thing down now. And thank you very much, everyone, for attending. Thank you, Rob, for a great presentation. Really appreciate it.
All right, 73. Thanks.
73s, everyone.
Thank you. It was great.
I trust this program is being recorded and will be available on YouTube, so because we can't possibly get it all in one sitting.
Yes.
Yeah, I'll make it available probably by tomorrow morning.
Okay, thank you. Thank you, and my compliments to both of you, and my compliments to you all for hosting it.
Well, we're in this for a long run, so stick around. We have hopefully have a lot more of these kind of things. 73s, everyone.